put this together?
Yeah, so as everybody said, big data is kind of one piece of a bigger puzzle. Customers are looking for a complete solution that they can plug in and actually just spend time running their business versus going out and building solutions internally. So, the old model of going and picking a ton of pieces and vendors off the shelf, spending months putting it together, waiting 6 to 9 months for someone to come back with data that you can analyze to run your business, that doesn't work.
So one of the things that we have consistently have managed to do is not to reinvent the same thing again and again. So for example, when we actually envisioned about data flow machine learning, the technology itself, we had one thing in mind that we did not want to introduce another engine. So, if you look at the traditional ETL companies that are going obsolete right now, they are introducing their own engine where they feed the data into this engine. But what we think is the future is that this open source community is so rich and there are so many people who are working on it. We need to leverage those contributions. So for example, our Oracle Data Integrator never had an engine. So we followed the same principle, and even in Dataflow, we don't have an engine. We use the Spark libraries, we use the machine learning capability, we use the algorithms from natural language processing, and then we actually combine all this information, and we can process them natively on a Hadoop platform, which is an open source platform, right? And then lo and behold, you can get more insights into your.
That's pretty exciting. We've been continuing to innovate, as you know. We've been expanding our portfolio, and the big focus is on choice. So with the big data appliance and the big data now taking that to the cloud at customer strategy, we're able to now give customers choice of doing their big data analytics on-premise, in the cloud, or as a cloud service behind their firewall. It's a huge innovation, a whole new change to the way you can do things for our customers.
I still think that one of the key aspects to getting access to that data is SQL. And so that's one of the ways we are driving, right? Try to figure out, can we get the Oracle SQL engine and all the richness of SQL and analytics enabled on all of that data, no matter what the format is or no matter where it lives, how can I enable those SQL analytics on that? And then obviously we've all seen the shift in APIs and in languages, like people don't necessarily always want to speak SQL and write SQL questions or write SQL queries. So how do we then enable things like R? How do we enable Perl? How do we enable Python? All sorts of things like that. How do we do that? And so the thought we had is, can we use SQL as the kind of common metadata interface and the kind of common structure around some of this, and enable all these languages on top of that through the database? So that's kind of the baseline of what we're thinking of enabling this to developers and large communities of users.
I think it starts to dissolve as a standalone department, but it becomes ingrained in everything that a company does. Your IT department shouldn't just be fixing fax machines or printers. They should really be driving the way that you do your business and think about your business. What data you collect, how you interact with customers, capturing all of those signals and turning that signal into noise, turning filtering out the noise, turning the signal into action so that you can reach your customers and drive the business going forward.
So IT becomes part of the fabric of the business model, so it's IT everywhere.
Exactly. So
Thanks, John. As you know, we're WANdisco, Wide Area Network Distributed Computing. We do replication over the WAN. And the modern data center looks a lot like WAN links with cloud components and on-prem custom hardware such as the Oracle BDA. In that world, the replication capabilities we bring are very important to customers. We are the only solution that does a Paxos-based, strongly consistent replication, which means zero RPO, zero RTO, great availability of data. If you want to take your enterprise-grade applications to production, we are the only path to doing that.
So yeah, it's an interesting phenomenon, right? It's everyone thought Hadoop is the next great wave, and the reality is, if you go talk to customers, they're like, yeah, I've heard of Hadoop, but what do I do with it? So it's like apps is what's going to drive this whole stack forward. And to that end, the number one thing that people are looking for is 360 view of customer. They all want to know more about customer. I was talking with the customer who represents the equivalent of the tax bureau of their country. And they instead of putting the customer, it's the taxpayer or the customers at the center and all the different places that you pay taxes. So they want to have one view of you as the taxpayer. So whether you're a public entity, private, the number one thing that the apps that people are looking for is show me more about customer. If I'm a bank, a retailer, they want to cross-sell, and they want to do that. That's the number one app. In telcos, they want to know about networking. How do I get this network? I want to understand what's going on here so I can better support my support center. But secondary to that, we're in this kind of a holding pattern now. What are the next set of apps? And so there's a bunch of startups here in Silicon Valley that are thinking they have the answer for that, and we're partnering with them, and we're opening up a cloud marketplace to bring them in, and we'll let customers decide what.
Well, when this whole big data thing started years ago, I mean, Hadoop just hit its 10th anniversary, right? Everybody was talking about throwing everything out, that they had, and there was no reason for SQL anymore, and you're just gonna, throw a bunch of stuff together yourself and put it together and off you go, right? And now I think people have realized that to get the real value out of these new technologies, it's not a question of just the new technologies alone, but how do you integrate those with your
Customers get, I think the old model of converged infrastructure was, hey, let's simplify some of the hardware components. And there was a big piece missing, which was, what are you doing with that hardware? Where's the software pieces? I think the real converged infrastructure that Oracle is bringing to the table and that customers are saying is, it's a complete package. It's not only the hardware, but it's the entire software stack as well. Because in the old model, if you have a converged infrastructure with hardware, what are you going to do with that? You need software components on top of that. So you're still kind of, building your own with VMware or others off the shelf. Now you don't have to do that.
So I think from a modeling perspective, the metadata part, we certainly look at it as a creation or definition language is probably the better word, right? How do I do structured queries, because that's what SQL stands for? How do I do that on JSON documents? How do I do that on IoT data, as you said? How do I get that done? And so we certainly want to create the metadata in like a very much a traditional database catalog, or if you compare to the Hive catalog, very much like that. The execution is very different, right? It uses the mechanisms under the covers that NoSQL databases have, or that Hadoop HDFS offer. And we certainly have no real interest in doing insert into Hadoop, because the transaction mechanisms will work very, very differently, right? So it's really focused on the metadata areas, and how do I expose that, how do I classify and categorize that data in ways people know and have seen.
How do you address that?
Yeah, we have done a lot of innovation in terms of database, addressing data management in general, right? So first of all, on the data integration side, we have had customers, the largest cell phone company in the world, moves data from an Oracle database to a Kafka-based queue to do further analysis, right? The largest electric car manufacturing company is actually trying to optimize their assembly lines in real time so that they don't lose money if the assembly line goes down. So we have done a lot of innovation and a lot of these customers are using big data type of technologies to get additional insights. So we don't stop them from taking data out from Oracle database or putting data back into Oracle database. Not only that, what we have introduced is
What's going on?
There's a lot. I mean, there's a lot of interest in the market around big data, but in terms of companies that are actually using that in kind of a productized fashion to build competitive insight are less than you would think because of some of these obstacles. So we look at it in a few different ways, and we try to tackle the obstacles at Oracle in each of these categories. I mean, one of the first big questions to solve is what you raised. How do I manage the data? I've got a lot of gravity in my data warehouse and in my databases, but now I've got all this new content coming in. It might be social media, it might be log data, things that you're not sure of the value, so it may not make sense to store in that enterprise data warehouse. That's really where customers are looking at alternate technologies like big data, like Hadoop, to give you both that cost savings, but also to give you kind of specialized access, whether you're doing, like you said, spatial queries or graph queries. Oracle can give you the right engine for the right job, but what's also important in that data management layer is doing it in a way that breeds kind of simplicity of ownership. If the cost of ownership is too expensive, no one's going to do that. So we also have an initiative called Big Data SQL that lets you use that common Oracle database as your front end, but then query back to Hadoop, query back to a spatial or graph engine. You can leave that data there where it makes the most sense.
I mean, SQL governance.
I think we were able to put a big step forward on it. And it sounds very simple, but we now have a central catalog, right, that actually understands what your data is and where it lives in kind of like a well-known way. And again, it sounds very simple, but if you look at silos, that's the biggest problem. You have multiple silos, multiple things are in there, nobody knows really what's in there. And so here we start to publish this into like a common infrastructure layer. We have all the technical metadata, we track who queries what, who does all of those things. So that's a tremendous help in governance. The other side, of course, because we still use native tools to, let's say, manipulate some of the data or augment or add new data, we now are going to tie in a lot of the metadata that comes from, let's say, the Hadoop ecosystem, again, into this catalog. And while we're probably not there yet just today on the end-to-end governance, everything's kind of out of the box, here we go.
And probably never will be.
We probably never will, you're right? And I think we set a major step forward by just consolidating it and exposing people to all the data they have. And you can run all the other tools like crawl my data and checkbox anything that says SSN or looks like a social security number, right? All of those tools are still relevant. We're just having the consolidated view dramatically improve.
Talked about data management, giving you the right engine. We talked about Data Factory, kind of giving you that integration capability. But why go through all that effort if not to start driving innovation? And that's what we think about as the data lab. It's a place where you can experiment with advanced analytics. It's a place where you can experiment with data mashup and new data combinations. And you do it in a cost-effective way, in a way that breeds this notion of agility. You mentioned the word system of record before. That's a very great description for the warehouse. You're not going to change your revenue definition or your customer dimension in the warehouse. That's what everyone uses. But Hadoop, people look at it as a system of innovation. It sits alongside the warehouse. You can put a lot of that same data in there. Often you'll put data that never made it into the warehouse. So you get that big data variety, and then you can use that to come up with new ideas. So that's really the essence of the lab, is bringing in more data sets, trying more combinations of data, and then also seeing if you can move beyond just descriptive and diagnostic analytics into predictive.
Yeah, I mean, I think the biggest thing is turning data into the central cornerstone of everything that you're doing. No longer can you say, I'm going to launch this project without explaining what data you're going to collect, what are the metrics going to look like, how do we know if it's working, how do we know if it's not working, that sort of infusion of data everywhere. And even as you look across like broader industry trends, things like IoT. IoT is really just the recognition that every device, everything needs to have a connection to the network and a connection to the internet and generate data. And then it's what you do with that data and tools that allow you to make sense of that data that are really going to drive you forward.
Deal with Rokana.
So Rokana is, an interesting play. What they have found is that customers, one of the ways they talk about themselves is they offer a data warehouse to IT. So if I'm the IT guy, I want to go in and have basically a pool of all kinds of log analysis. How are my apps running? Do I need to tune the apps? How's the network running? They want like a one bucket of, how can I better, how can my operation perform better? So what we've seen from customers is they've come to us and said, oh, okay, what do you got in this new space of Hadoop that can do that? Look at log analysis and, all kinds of app performance from a Hadoop perspective. They were, one of the people, that first persons to answer that. So they're having great success finding out where security breaches are, finding out where the network latencies are, just better, like I said, looking at logs and how the things could run better. So, so that's what they're answering for customers, basically improving IT functions, right? Because what's happening is a line of business people are in charge, right? And they're saying, I no longer want to have to go to IT for everything. I want to be able to just, go to basically a data model and do my own analysis off this. I don't have to call IT for everything. So these guys are, in some ways trying to help that model.
It's a combination. So when it comes to things like existing maintenance applications or existing service applications, the interfaces of them used to be manual, where someone will get a call and they will enter an order into the system or a work order. With IoT, those are being extended to have new channels. So for example, in our Service Cloud, we have added a new channel with IoT. So now the equipment itself reports the problem, and when the service technician gets a work order, they already know which part has gone bad. So the whole manual step is taken away. There are other areas where companies are trying to transition to this product as a service model, right? And so those need new ways of monetizing, new types of applications where you're capturing utilization. There you will need some new application. So it is a combination of.
I mean, what's interesting is that's an age-old problem. I mean, we had that with data warehousing. We have it even more now with all the big data sources. And I think the opportunity here is to decide who should solve that problem. Is it a scarce ETL developer that you have in IT? They have limited cycles.
That's true.
Do I have a data scientist? People actually use data scientists to do this sort of data integration work. It's hard to come up with a new predictive model if the data sets don't match up.
Yeah.
And it's unfortunate because that's the PhD guy.
Yeah.
And that's menial labor to a large degree.
It's hard to find PhDs too.
It is. I like to call them unicorns. You hear about them, you never really see them. And you definitely don't want the scientist doing that menial labor. The joke we say is that the data scientist has been turned into a data janitor because of all these tasks they could put on their shoulders. So we think at Oracle that's an opportunity. With this combination of data management, data factory, and data lab on top, you can actually push that work out to your business analyst teams. They can collaborate with IT, they can collaborate with your data scientist if you have them, but the spirit of the lab process.
So if we start with the business value, I think the biggest thing we bring to the table is simplicity and standardization. Right? If I have to understand how is this object represented in NoSQL, how in HDFS, how did somebody put a JSON file in here, I have to now spend time on literally digging through that. And then does it conform? Do I have to modify it? What do I do? So I think the business value comes out of the SQL layer on top of it. It all looks exactly the same. It's well known, it's well understood. So it's far quicker to get from, I've got a bunch of data, to actually building a BI report, building a dashboard, building KPIs, and integrating that data. Right? And there's nothing new to this. It's a level of abstraction we put on top of this, whether you use REST API, in this case we use SQL, because that's the most common analytics language. So that's one part of how it will impact things. The second is, and I think that's where the architecture is completely unique, we keep complete control of the query execution based on the metadata we just talked about. And that enables us to do global optimization, right? And we can, if you think this through a little bit and you go, oh, okay, global optimization sounds really cool, what does that mean? I can now actually start pushing processing, I can move data, and it's what we've done in the Exadata platform for years. Data lives on disk, oh, Peter likes to query it very frequently, let's move it up to flash, let's move it up to in-memory, let's twist the data around. So all of a sudden we've got control, we understand what gets queried, we understand where data lives, and we can transparently start to optimize exactly for the usage pattern a customer has. And that's always the performance aspect. And it kind of goes to, I think, the old saying of how can I get data as quickly to an end consumer when he really needs it? Mm-hmm. That's what this does, right? How can I optimize this? If I got thousands of people querying certain elements, move them up in the stack and get the performance, and all these queries come back in like sub-seconds. Regulatory stuff that needs to go to like 5 years of data, let's put it in cheap areas and let's optimize that. And so the impact is cheaper and faster at the end of the day. And all because there's a singular entity almost that governs the entire data, that governs the queries, that governs the usage patterns. I think that's what we uniquely bring to the table with this architecture.
Yeah, I mean, you know, for some customers, it's a real concern, right? And the world is dynamically shifting. I mean, you know, look at what happened a few months ago with, you know, the Brexit, right? I mean, all of a sudden it was okay to have, you know, the data as long as it was in the EU. Well, the EU is now shifting. So where does the data go, right? So from a regulatory point of view, we haven't fully settled, right, in terms of where customer data can be held, exactly how it's treated, and you know those things are evolving. So for a number of companies, they want the advantages of the cloud, but they don't necessarily want it on the public cloud, right? And that's why you know we're offering these new cloud machines, because they can essentially have you know their cake and eat it.
I think the first hurdle was just making sense of big data. It took organizations a couple years just to get their head around that and to build that architecture so it will scale and people will adopt the system. I think the opportunity now, is, at least as we see it in our analytic portfolio, is you've got these users on the system, you've got these Hadoop clusters in place. What can you do with that power? And we think the big opportunity, especially as we create these data scientists, these citizen data scientists, is machine learning. How can we embed, especially the Spark machine learning libraries, into our products more natively, such that you don't have to have the PhD at the outset? You can use that compute power, and you can use the Spark open source libraries to help bootstrap that process.
And non-Oracle.
You know, I think if you look back at kind of the old mainframe days, if you could basically have a hardware system and the software working together and designed to work together, you have the best system, best of breed. I think, you know, because there were missing technologies back then, we moved to this kind of open client model. We would kind of have hardware, you would put some third-party software on there, and you would try to configure it yourself to make it work. Most companies would actually prefer if that system arrived ready to go. So we're kind of, in some ways, we're taking the best of both worlds, the best of that optimized system from the past with the ability of, that configuration, that methodology and technology that we have nowadays, and we built a system that basically
Yeah, basically, if you look across the industry, regardless of if you're in retail or manufacturing, your biggest competitors are the companies that have native digital advantages. What we mean by that is these are companies that you think of as tech companies, right? Amazon's competitive advantage in the retail space is that their entire business is instrumented. Everything they do is collected. They collect logs and metrics for everything. They don't view IT as a separate organization. They view it as core to their business. And really what we do at Rokana is build tools to help companies that aren't digital native compete in that landscape, get a leg up, get the same kind of operational insight into their data and their customers that they don't otherwise have.
Excellent. So the first one I would say by far, and I wish it wasn't the case, but it's helped me justify building out my big data cluster. That's the first one. Lots of companies want to do more with big data, but they're struggling
ROI
with
or cost or both?
The ROI, the cost, really, why should I make that investment? How do I justify it? And I really do think that cloud is going to change that picture dramatically. When I can shift to looking at the CapEx versus OpEx. And
so you're saying the cloud lowers the bar in terms of getting value generated, or is it?
It does two things. It lowers the financial entry point and how much you have to justify up front, and it lowers the IT skill set to manage those clusters in the data center. So two very big problems.
Great, that's awesome. Second one?
Now I've solved that. Second one is, okay, well, what do I do next? How do I find things? Really, where should I be looking? And that is where this data lab concept is meant to come into play. Some customers will have a perfect use case in mind. That's how they justified the project. They can go and execute that. But a lot of them, again, it's this notion of a data lake. I need to pursue a range of experiments.
Yeah.
Where do I start? And tools like Big Data Discovery help a lot there.
So data lab is just kind of play with the data and get a feel for it.
Yep. And do it in, like I said, do it in a way that breeds that experimentation, not just to visualize the data, but change it, reshape it, build new models, build new classifications. The last thing I'd say is, okay, did I get my ROI? Do I have a cluster? Yes. Did I figure out something that looks interesting? Yes. Now I have an idea. What do I do next? It's how do I connect my insights from big data back to the tools that we use.
So this is where the value of the data capital thing you're talking about. The lab is essentially formulating the key connections for data pipes to connect in.
Yep.
Is that kind of
roughly
the best way to think about it?
Yeah, you come up with new ideas, new data products.
So you've operationalized it by the third step.
Yes. Awesome. And then how do you do that? In some cases, it's, I just push the data, I move the data over to my data warehouse, which may make sense. But Oracle also has, I think I mentioned it before, Big Data SQL as a product, which will let you keep that data in Hadoop, keep everything else in your data warehouse, and productization is that easy. So you don't have to worry about.
So what we're seeing is that Homebrew is out. It's engineered appliances, it's cloud solutions, and a plethora of these. It's not just one specific application like Hive. There are many legitimate choices for solving the problems, and the one underlying problem that remains is getting consistent data to all of these applications. That's where we step in. An analogous example would be to consider the cell phone market, right? 15 years ago, there were Nokia communicators with a primitive form of email, then BlackBerrys with email again. But now you see the Apple iPhones and the Android machines. The infrastructure that supports apps running on those is phenomenal. It took a lot of work and a huge amount of software to make that work. We feel that we play that sort of a role. In the Oracle BDA, the replication capabilities we bring extend the data center to beyond that single BDA to perhaps a cloud instance of a BDA, perhaps a cloud instance of another distribution. That sort of cross-platform replication is what
15 years we've been helping our customers to move data from various systems, sources, and targets. So our products consist of a real-time data integration product, which is used for continuous availability or real-time replication, which is Oracle Golden Gate. It's our marquee product. It's been around for 2 decades. We also have an ETL product called Oracle Data Integrator, which is a product that actually takes the data and then it transforms the data in the source and the target itself. So it's not like the older technologies where you pull the data out of the system and process it in a middle tier. Instead of that, we actually leverage the power of the source of the target. And that's where we started. We have a data quality suite and a complete data governance foundation. So, we have about 12,000 customers, talk about the largest banks, largest telcos in the world. Each and every one of them use our products. So that completes our data integration product portfolio.
So what is this new data integration cloud suite we've been hearing about? Because that's interesting, ties into that. Does that relate, and how does that relate?
Absolutely.
Sure. So if you look at companies embarking on a journey to IoT, we see them go through sort of multiple phases. They start with just connecting their assets. So they have assets sitting on the field, not connected to the business systems. They start connecting them so that they can get real-time visibility into the assets and they can react more quickly to any problems that occur. So now they've reduced the time to react to any issues. That gives them sort of immediate ROI, but soon after they want to move to more of a proactive monitoring. So they're collecting information from all these assets, and they want to do predictive analytics and reduce unplanned downtime and predict failures before they actually happen. Once they do that, then they want to transition to using IoT data into their core business processes, whether it be back office supply chain processes, ERP processes, or customer-facing processes like CRM, where they start to use IoT data to provide differentiated experiences. And the IoT offerings that we provide essentially help them go through this journey from connected assets all the way to service excellence.
Customers have choice in terms of what they want to do. Again, the high-level thing for the analytics piece is they want to basically take that data and make a business decision out of it. And we're giving them the option of doing that where they want, when they want, and on what platform they want within Oracle. So if they want to do public cloud, they can. If they want to build their own private cloud on-premise, leveraging our technology, they can. If they want to go with the old model of a converged system on-premise, they can. Again, we're letting them do that, and it's a system that's really easy. It works across all three areas, and it's basically just plug and play.
Well, it's well integrated into the Oracle BDA. It extends the on-prem BDA to perhaps a cloud instance of the BDA or another on-prem instance in a different location. We even have a number of customers with BDAs side by side, and they're replicating across those.
Well, when we think about competitive strategy with data capital, we think in terms of the three principles of data capital, is what we call them. The first one is that data comes from activity. The second one is data tends to make more data. And the third is that platforms tend to win. So these three principles, if we just run through them in their turn. The first one, data comes from activity. This means that in order to capture data, your company has to be part of the activity that produces it at the time that activity happens. And the competitive strategy implication here is that if your company is not part of that activity when it happens, your chance to capture its data is lost forever. And so this means that interactions with customers are critical targets to digitize and datafy before the competition gets in there.
So if many of our customers are going through these digital transformation or Industry 4.0 initiatives, if you will, and there are some common patterns emerging when it comes to IoT, things like machine safety, predictive maintenance, production reliability, worker productivity, supply chain optimization, and all of these need extensions to existing applications or new types of applications. So Oracle's approach to IoT is to provide IoT-enabled smart applications for things like manufacturing, fleet management, asset monitoring, equipment prognostics, things like that.
Well, I think that's the whole value proposition around what we've done with the big data appliance. What we heard from a lot of our customers is they can go build their own, and they can put it all together, but then they have to maintain it, they have to manage it, they have to make sure that everything that all the software that they put together is going to work together, and they're going to be able to keep it up to date. We actually eliminate all the steps, a very vast majority of the steps it takes to bring it up online. So we can bring the time to value for doing your data analytics down to days instead of weeks.
Okay, so we started about 3 years ago on the Hadoop side by making an appliance made for Hadoop, and then in the future, which followed on with Spark. And that appliance has been doing well in the marketplace, for a number of years. And we've obviously continued to enhance that. We then took what we perfected on premises and we moved that up to the cloud. So we have a big data cloud service for customers that offer them, high performance access to Hadoop and Spark. and without the necessarily the need to actually manage security and all the things with it, right? At Open World, we'll be making a series of announcements. We'll be creating yet another big data cloud service. This one will be fully managed, fully elastic for customers who only want to take advantage of a Hadoop or Spark service, as an example, and don't want to deal with the ability to specifically tweak the environment, right? We also announced a little while ago our family of cloud machines, right? So you'll see the first cloud machine is one that provides Oracle IaaS and PaaS services, and then we'll add to the family.
That's shipping already, though.
That's shipping already,
Okay.
right? And then we'll add to the family an Exadata cloud machine and a big data cloud machine. And the cloud machines are really kind of a cool concept. They're cool because, for a lot of customers, from a regulatory point of view or otherwise, they're just not ready for the public cloud. But everybody wants to take advantage of what the cloud provides. So how do you do that behind your firewall, right? How do you provide IT as a service? So what Oracle has done essentially is to package up its cloud services and able to deliver that to customers behind the firewall. And they get the exact same technology that they have on the public cloud. They build to one architecture and then deploy it wherever they choose. They get the advantages of the cloud. It's a subscription service, right? But they can they can adhere to whatever data sovereignty or issues that.
One of the big trends.
Oh yeah, absolutely. I mean, whenever you talk about machine learning, you want the real-time insights from it, but it's only as powerful as the historical data that you have to build those models. And so a big thing that we focus on is how to make it easy to build those models, how to do it automatically, how to get away from having 500 different tunables that the customer has to set, and really put it on autopilot.
Well, making it easy, but also fast, right? It's got to get in low latency. That's another one.
Oh, absolutely. I mean, we leverage Kafka for just that reason. We're able to bring in, millions of events per second into moderate-sized environments without.
So the first thing that customers experience, the first problem, is that the data is not current, because all the solutions offered by the distro vendors are batch. They run once an hour, and then it takes too much CPU, so they run once 4 hours. Often you have to run it once a week when there's no load on the system. We offer continuous replication. Every change that's made in either of the systems, remember both systems are active, that's the magic of our solution. The changes are coordinated and replicated. So that immediate availability and the zero RTO disaster recovery capabilities shines as the biggest feature for all.
Well, what we're saying with Data Capital is that data fulfills the literal economic textbook definition of capital. So capital is a produced good as opposed to a natural resource. You have to invest to create it. And it is then a necessary input into some other good or service. So when we define data capital, we say that data capital is the recorded information necessary to produce a good or service, which is really boring. So let me give you an example. So picture a retailer. A retailer wants to go into a new market. To do that, the retailer has to expand its inventory, has to extend its supply chain, it has to buy property, all of these kinds of investments. If it lacks the financial capital to make all of those investments, it cannot go into that new region. By the same token, if this retailer wants to create a new dynamic pricing algorithm or a new recommendation engine, but lacks the data to feed those algorithms, it cannot create that ability. It cannot provide that service. Data is now a kind of...
All of the above. There was some engineering involved, but all that's done. As far as the customer is concerned, it's completely integrated, well supported, and as any engineered appliance should offer, it's a single point solution for the customer.
So you bring your unique secret sauce and replication to the Oracle BDA, and does this extend to the cloud machine stuff?
Yes, it extends to the cloud machines. It extends to distributions other than what you may be running on the BDA. It extends to cloud instances where the storage can be different, S3 for example, or an object store such as the Swift one that other cloud vendors are providing. We replicate across all of those very well.
It's like three things. I think it's three things. It's ingesting the data, right, from news sources that we outside of the company, so sensors and social media, right? That's one thing. Secondly, it's then managing the data, which we've always done. And then the third thing is analyzing it. So it's that whole continuation. And then what's happened here is the management platform has expanded. It's gone from just a relational base to this whole NoSQL world and this Hadoop world, which we completely support. And we're by no means is this relational a zero-sum game, right? Where it's relational or nothing at all. We've expanded the whole data management platform to meet the criteria of whatever the application is. And so these are the 3 data management platforms today. Who knows what's going to come tomorrow? We'll support that as well. But the idea is choose the right platform for the application. And what it's really becoming about is applications, right? And this data management stuff is obviously table stakes, but how do I make my applications dynamic and real time based on what I have here?
Well, the basic answer is to go where the money is. So there are a couple of things you can do with data. One is that you can improve your operational effectiveness. And so here you should go look at your big cost areas and focus your limited data science and managerial resources on trying to figure out, hey, can we become more efficient in whatever your big cost driver is? If it's shipping and logistics, if it's inventory management, if it's customer acquisition, if it's marketing and advertising. So that's one way to go. The next big thing that you can do with data is try to create a new product or service, create new value in a way that generates revenue. So here there is a little caveat, which is that companies may also want to consider creating new capabilities, maybe enriching the customer experience, making connections across multiple channels that they can't actually charge for, not today. But what they get is data that no one else has. What they get from, let's say, making an investment into bring together the in-store shopping experience with the with targeted emails, with communication through social feeds and through Twitter. Let's say that they invest in trying to tie that data together to get a richer picture of their consumers' behavior. They might not be able to charge for that today, but they may get insight into the way that shopping experience works that no one else can see, which then leads to a value-added service tomorrow. And I know it all sounds very speculative, but this is basically the nature of prototyping of new.
Okay. So recently we released an IoT cloud service, and the main difference in our approach to IoT versus many of the other vendors is we look at it from the applications out, as you said, from the business out, right? We want to take the insights from these devices, the data coming, and make that actionable within your enterprise business processes, right? So the goal of IoT cloud service is to actually bridge this gap between the operational technology and the IT world. And we do this by providing out-of-the-box applications as well as platform components. I talked about applications like asset monitoring earlier. So there we have out-of-the-box app that helps you answer questions like, how are my assets being used? What is their health? Do they need to be serviced? You look at equipment monitoring, it's about how are my systems doing on the factory floor? Collect data from them constantly so that I can decide which ones to service in the next maintenance window, right? Now, I'm collecting all this data. This has to be backed by sort of platform components. And our platform components fall in sort of these 3 broad categories, right? Connect, analyze, integrate. So the connect part is where you bring the device, onboard the devices, and provide bidirectional connectivity to them. So we have this concept called device virtualization, which really simplifies how you interact with these devices and provides a software representation of those devices in the cloud. So now any application interacting with it doesn't need to know the gateways and the protocols that are used. On the analyze side, there are 2 types of analysis. There's real-time analysis, which is done on the event stream. And then there's big data analysis that's done where you combine the real-time stream along with contextual data sitting in your data lakes or your ERP systems, and then you apply predictive algorithms on top of it. We have a bunch of capabilities here. We provide business user-friendly interfaces to model these event processing functions, and we also provide built-in algorithms using our big data services for things like equipment efficiency, remaining useful life, things like that, right? So Big data and IoT are quite related. If you look at the big data techniques like Spark, Hadoop, or some of these services, the type of data they operate on, data with high velocity, high volume, high variety. IoT data has all of the same characteristics of that big data, right? Now, once you have analyzed this data, you also want to integrate it with your backend systems, and that's where we provide out-of-the-box connectivity with our SaaS apps, as well as our e-business suite and our JD Edwards applications, which are commonly used by our enterprise customers. You have the connectivity piece, you have the analytics, and you have the integration. You use these capabilities along with some of our other PaaS services like our Business Intelligence Cloud service or our mobile cloud service to build your IoT application.
I think specifically from a big data SQL perspective is we're going to drive the possible adoption scope much, much further. Right, today we work with HDFS and we work with Oracle Database. We're going to announce certain things like Exadata to Commodity Hadoop will be supported. We'll announce supercluster support. We're going to dramatically expand kind of the footprint big data SQL will run on. People who come for like big data SQL or analytics sessions, you'll see a lot of the roadmap looking far more forward. I already mentioned some things like ground to cloud. How can I run big data SQL when my Exadata is on premise and then the rest of my HDFS data is in the cloud? Right, and we're gonna be talking about how are we going to do that and what do we think the evolution of big data SQL is going to be. I think that's going to be a very fun session to go to.
Yeah, so there's in this big data world, what we're seeing a lot of is customers do a lot of what we call lab experiment. So they got all this data and they want to do lab experiments. Okay, great. So then they find this nugget of, okay, here's a great data model. We want to do some analysis on this. So let's turn it into a production app. Okay, then what do? How do you take it production? These are the guys that you would call. So they take it into an HA, high availability environment for you, and they give you zero data loss, zero downtime to do that. One of the things that Oracle's we're touting as a differentiator in our cloud is this hybrid approach, where you have you can start out doing test dev in the cloud, bring it back on-prem, vice versa. They allow you to do that sync, that link between the cloud and on-prem. They also we work today with Cloudera. We OEM them in our big data appliance. If the customer has Hortonworks, but they also want to work with our stuff, they're go between with that as well. So it's basically they're giving you that production-ready environment that you need when you do that.
Of course you can. Oracle is absolutely all about choice. It's the ability for you to be able to use both Oracle and non-Oracle source data in a single appliance and do your analytics against that. That's the value of the big data appliance.
So we very much believe, when Oracle started, it was all about database and it was all about SQL. And we believe now that the new normal is really one that includes both Hadoop, NoSQL, and relational, right? SQL is, of course, still a factor, but so are the ability to interface in via REST interfaces and scripting languages. So for us, it's really a big tent. And we've been taking what we had done previously in database and really extending that to data management over Hadoop and NoSQL.
I think it's a couple things. One, they don't want to spend their time becoming IT experts anymore. And so the value of an appliance like technology or a cloud service, either one, is exactly what they're looking for, because they want to simplify their IT infrastructure and they want to focus on the things that matter most, which is the applications that drive the business. So that's number one. Number two is they're worried about cost. And so they would like to have cost be specific and more transparent. So they want to make sure that whatever they're spending, they can actually allocate back to the business units. That's coming from the IT side. Mm-hmm. So having cloud-based models actually helps quite a bit with cost transparency. And I think the third thing is that overall, they want to make sure that they can get things done faster. And so the idea of having cloud services gives them that agility that they need. I know you only asked for three, but I would say the fourth thing is they're looking for choice. They really want to understand, they want to make sure that if they choose one model, that they're going to be able to flip and they're not going to be locked in. And what Oracle's done with this is given them the capability to either deploy on Oracle, work with Oracle and non-Oracle data, and you can do it on a cloud or you can do it on-prem. It's all up to you.
Yes, I think one of the things that we have done at Oracle is we have been in the forefront of innovation. So a lot of times, we do solve enterprise level mission critical use cases, but one of the things internally that we have done is we have been constantly embracing real-time open source technologies, big data technologies, and cloud technologies. One thing that we have observed in the marketplace is The traditional ETL is like driving a car using your rear view mirror, right? So you're not actually analyzing the data as it's coming in. You're actually have moved the data, transformed the data, and looking at the data and started making decisions. Instead of doing that, what we think is we have built a new platform where we can analyze data as it's flowing through. So let's say your transactions are coming in. You want to detect any fraud on your transactions, banking transactions. What we can do is now we can feed the data, capture the data using Golden Gate, and
customers. Yes. So there is definitely a lot of buzz about IoT, and it is affecting a lot of industries, whether it be manufacturing, transportation, home automation, fleet management. And we expect around 50 billion devices to be connected in the next 2 to 3 years. And even the devices already connected today are generating over 5 zettabytes of data, and very little of that is actually real.
Zettabytes.
Exactly.
So zettabytes is megabytes, gigabytes, terabytes.
Exabytes, and then zettabytes.
A lot of data.
A lot of data. And very little of that is being actually used. And if you talk to any analysts, they project somewhere between a $1 to $5 trillion market, right? But numbers aside, there is real business value here. I mean, some companies are looking at IoT to improve operational efficiencies. Others want to use IoT to improve the customer experience or create sort of new business models and new revenue streams. So there are clear opportunities here, and that's what's attracting a lot of these organizations to IoT.
So we talked about the modeling already. So the first step is that we extended the Oracle database and the catalog to understand things like Hive objects or HDFS, kind of where does stuff live, right? So we expanded that, and so we found a way to classify the metadata first and foremost. The real magic is then into leveraging the Hadoop stack. So you ask a BI question and you want to join data in Oracle, transactions, finance information, with, let's say, IoT data, which you're going to reach out to HDFS for. Big Data SQL runs on the Hadoop nodes. So it's local processing of that data, and it works exactly as HDFS and Hadoop work. In other words, I'm going to do processing local. I'm going to ask the name node, which blocks am I supposed to read? That all gets run. We generate that query, push it down to the Hadoop nodes. And that's when some of the magic of Big Data SQL kicks in, which is really focused on performance. It's performance, performance, performance. Right? That's always the problem of federated data. How do I get it to perform across the board? And so what we took
predictably.
Predictably, that's an interesting one. Predictable performance, because sometimes it works, sometimes it doesn't. So what we did is we took the Exadata storage server software with all the magic as to how do I get performance out of a file system, out of I/O. And we put that on the Hadoop nodes. And then we push the queries all the way down to that software. And it does filtering, it does predicate push down. It leverages features like Parquet and ORC on the HDFS side. And at the end of the day, it kind of takes the I/O request, which is what a SQL query gives, feeds it to the Hadoop nodes, runs it locally, and then sends it back to the database. And so we filter out a lot of the gunk that we don't need because you said, oh, I only need yesterday's data or whatever the predicates are, right? And so that's how we think we can get an architecture ready that allows us to do global optimization, because we can see the entire ecosystem in its totality, IoT, Oracle, all of it combined. We optimize the queries, push everything down as far as we can, right? Algorithms to data, not data to algorithms. And that's how we're going to run this predictably performant on all of these pieces of.
In manufacturing world, when you're doing these IoT kind of solutions, there's a common analysis done called the 5M analysis: man, machine, method, material, measurements. Right? Mm-hmm. Now, if you look at man, method, materials, all of this information is sitting in your ERP system or your databases, where you have who operated on the system, what training did they receive, what techniques did they use, what raw material was used, who was the supplier. You look at machine and measurements, this is raw data coming from the equipment, IoT data, and measurements is around the tests that were done on the system. You need to combine both of these to create a real predictive analytics solution for manufacturing, right? Now today, a lot of this has to be done using sophisticated sort of data scientists, and you need sophisticated developers who can operate on these various big data components, whether it be Spark, Kafka, Cassandra, all of these. What we are doing at Oracle is trying to provide sort of tools and frameworks that abstract away some of that and are targeted towards the citizen developer or the business user. So you don't need to have sophisticated data scientists, right? We have tools such as big data discovery, big data prep, and other tools such as machine learning, which make it easy to build these kind of models. Now, if you are a developer who wants to write all of this from scratch, even then, when you're dealing with different types of structured and unstructured stored, you need an abstraction layer that simplifies how you interact with this, how you query it. And so we are providing SQL-like interfaces that they're already familiar with. So whether it's a structured store or unstructured store, and whether it doesn't matter which native query interface it supports, we provide a standardized layer so that they can easily operate with the data. Now, even that takes a long time to build an IoT solution. So that's where our out-of-the-box applications come in. And by providing these out-of-the-box applications for specific use cases around asset monitoring, equipment prognostics, supply chain, we are really trying to reduce the time it takes for you to deploy an IoT solution, because these applications already have those built-in algorithms. All you're doing is configuring them, providing some parameters, but you don't need to write the algorithm. You take your industrial gateways, connect the devices, and you're ready to go.
Companies are moving toward a hybrid cloud big data architecture.
What does that mean?
It means that almost all the buzzwords are used, and we're going to need new ones. No, what it means is that companies are going to find themselves in a situation where some of their computing activities, storage, processing, application execution, analytics, some of those activities will take place in a public cloud environment. Some of it will take place within their own data centers, reconfigured to act as private clouds. And there are lots of potential reasons for this. There could be, companies have to deal with not only existing regulations, which sometimes will prevent them from putting data up into a cloud, but they're also going to have to deal with regulatory arbitrage. Maybe the regulations will change, or maybe they've got agreements with partners that are embodied in service level agreements that again require them to keep the data under their own observation. Even in that case, the business still wants to consume all of those computing resources inside the data center as if they were services. But the business doesn't care where they come from. Right. And so this is one of the things that Oracle is providing, is an architecture for Oracle Public Cloud and private cloud in the data center that is the same on both sides of the wire. And in fact, can even be purchased in the same way. So that even this Oracle Cloud at customer, these machines, they are purchased on a subscription basis, just as public cloud capabilities are. And the reason this is good is because it allows IT leaders to provide to the business computing capabilities, storage capabilities, as needed, that can be consumed as services regardless of where they come from.